8.3 is the graphs of sinusoidal functions. Now you might remember me saying along the way that a sine graph and a cosine are the exact same graph. This cos is just a shift of the sine. Sine starts at 0 for just a basic y is equal to sine x, starts at 0 and goes up to 1. Whereas a cos graph, y is equal to cos of theta, is, or cos x, whichever you want to use, your cos graph starts at 1 and goes down to 0. So you just sort of slide it along until you can see that they resemble each other. So a sinusoidal function is any periodic function whose graph has the same shape as that of sine, y is equal to sine x. So a y is equal to sine x graph looks like that and would repeat. A cos graph, so this is a sine x graph, cos graph goes like this and repeats. But you can see if I were to draw a line, and well, this isn't quite. If I were to draw a line, so we've got this, here's our midline. For this one, our midline would be a little bit lower, but you can see it's crossing at 0, crossing at 0, going back to 0, up to 1, up to 1. It's just shifted a little bit over where that starts. So a sine graph actually starts right here. Our cos graph starts right there on a sine graph. I'm going to erase that beautiful artwork. So key ideas that we're looking with. The range is our maximum value minus our minimum value. Or you could write it as maximum minus minimum. So your range, when you go to write it out as domain and range, tell those to me, is a set of values for y where minimum less than or equal to y is less than or equal to the maximum. And y is an element of real numbers. So your range is always in between your minimum and your maximum value, which only makes sense because that's as far up or down as you could go. Amplitude then is that maximum minus minimum divided by 2. Your equation of the midline is similar to this, but it's maximum value plus your minimum value divided by 2. And again, it's an absolute, because you're measuring distance, it's an absolute value. So your period then is the horizontal distance between consecutive maximum values or minimum values. Oops, better fix that. Values. Okay, so some examples. The sine curve below shows a person's height above the ground as the person rides a Ferris wheel. Label the range, amplitude, midline, and the period. Okay, so the range then is the distance between the maximum and the minimum value. So we're going from here to here. So that's 15 minus 5, which is 10 meters. So if we were to write this, then the range is a set of values for y such that y is in between 5 and 15. The amplitude then, so amplitude is your maximum minus your minimum. So my maximum minus my minimum divided by 2. So that's 10 divided by 2. So it equals 5 meters. So my amplitude then is at 5 meters. I'll just do a little squiggle. Next one says the midline. So midline was y is equal to the maximum plus the minimum divided by 2. So that's 20 divided by 2. So then the midline is at y is equal to 10. So right here would be my midline. Okay, and then the last one says we need to know the period. So the period is the distance from maximum values, or between maximum values, or between minimum values. So it doesn't matter which one you choose. I haven't used blue. So if I look at the minimums here, so I'm going from this point to that point. Well, the period is equal to 8 minus 4, which is 4. In this case, this would be minutes, because we're dealing in minutes. If I did it on the top, to go from my maximum to my maximum, I'm going from 2 to 6. So 6 take away 2 is also equal to 4. So you can see how I get the same value. Okay, example 2 says the diagram below displays some of the key information about a particular Ferris wheel. One ride lasts 600 seconds and completes 10 rotations. So 600 seconds, that's 10 minutes. It's a heck of a long Ferris wheel ride. And it only does one rotation in a minute. It's pretty slow too. Okay. So here's the ride. They're saying you start the ride here at the midline is where they're saying. That's obviously not where you get on, but for our purpose of calculation, that's where we're going to say it starts. So it says complete the table below to show a rider's height above the ground. So time on the ride at 0. If this is 0 here, then he is at 10 meters. 15 seconds into the ride. So we need to figure out where he is at in 15 seconds. So if it takes, just to do the calculation, 600 seconds to complete the ride, and there's 10 rotations, we know then that it's 60 seconds per rotation. So 15 seconds then out of that, 15 out of 60 is going to be 1/4 of the ride. So at 1/4 of the ride then, he's gone from here to here. So this is 1/4 of the ride there. So his height then would be at, we have 10 meters to the midline, or to that, and I shouldn't call it the midline, to that line, and then, or to your starting point, and then another 8. So that'd be at 18. So 30 seconds then is going to be halfway through your rotation. So we're going to be here. So there we're back at 10. 45 seconds puts us there. So we're at this height. The one piece of information not included in here is that you are starting, or the Ferris wheel is 2 meters off the ground. So your height would be at 2 meters. 60 seconds then puts us right back at our starting point, so we're back at 10. 75 seconds is another quarter rotation, so you're up at 18. 90 seconds then, you're back at 10. So B part says, sketch a graph to represent the rider's height above the ground during the ride. Label the range, amplitude, midline, and the period. Okay, so let's start first with labeling our axis. So our x value is our time in seconds. Our y value is our height in meters. So what we could do here is mark these off in every 2 is 15 seconds. So if that's 15, this would be 30. This would be at 60. Right. Oh, hang on, I'm going to do this. This one's a little bit bigger, sorry. Every 4 will be 15 seconds. So and then this will be, what am I at? 105, which is a little bit further. So we can just label these at each tick is 1 mark. Okay, so now we can start plotting this. At 0 seconds, he was up at 15 meters. So he was up at 10. At 15 seconds, he was at 18. At 30 seconds, he was back down at 10. I'll make sure my 45 seconds, he was down at 2. 60 seconds, he was back at 10. 75 seconds, he's up at 18. 90 seconds, he was back to 10. So then we know if we went the next 105 seconds, then he would be back down here at 2 if we were to continue past that. So our sinusoidal function looks like that. Whoops. Oh, I put that at 1 instead of 2. And it'll continue back up. Okay. So we want to know the range for this. So range is your maximum minus your minimum. So 18 minus 2, which is 16. So set of values for y such that, whoops, y is between 2 and 18. Amplitude then. Amplitude, excuse me, was your maximum minus your minimum divided by 2. So 18 minus 2 divided by 2, so 16 divided by 2 is 8. midline is equal to your, so y is equal to your maximum plus your minimum divided by 2, so that's 20 divided by 2 is 10. So your midline, and you can kind of pick it off of your graph here, occurs right there. And our amplitude then is the distance that you go off that midline. Okay. What else did it ask for? Oh, the period of the graph. Oops. That's not making sense. I'm on the wrong page. Okay. And then your period from the graph to go from maximum to maximum. So from here to here. So that was at 15 seconds to 75 seconds. So the period is equal to 60 seconds. So the last part says, how is this graph and Ferris wheel different from the graph and Ferris wheel in example 1? So if you look at the 2 in the first example, you were only going, your amplitude was only 5. So that means you were only going, or you're going less meters off of the ground in the first one than in the second one. That also means then your diameter of the second Ferris wheel was a lot higher, because with that 5, that amplitude of 5, that's just showing you how high your Ferris wheel is, or the radius of your Ferris wheel. So Ferris wheel number 2 has a bigger radius, which means it has a bigger diameter. And you can tell that also from the range. And if you looked at the 2, your period was a lot shorter as well. So that means that Ferris wheel number 2 rotates faster because your period was equal to 60 seconds. And the other one was equal to 4 minutes. Okay. Example 3. The original Ferris wheel designed by George Ferris in 1893 could carry 2,160 people at a time. It has a maximum height of 80.4 meters and a radius of 38 meters. So it says fill in the table below for the height above the ground of a person on the Ferris wheel. Assume that the person got on a ride at the wheel's lowest point and that one rotation took 16 minutes. Okay. So we have to put some of the information on here. We know that up here, at this highest point, there was a height of 80.4 meters. They tell us that the Ferris wheel had a radius, so to go from middle to here, that was 38 meters. Actually, I'm going to put this on the other. That doesn't matter. So from here to here was 38 meters, or from here to here is 38 meters. So that means that it had a total diameter of 76 meters. So if this total distance from here, I'll do this in red, was 80.4 meters, then that means that our distance from here to here is the difference between total distance minus the diameter of the Ferris wheel. So the height off the ground is equal to 80.4 minus 76, which is a value of 4.4 meters. So this distance here is 4.4 meters. So then starting at 0, we're starting right here, we are 4.4 meters off the ground. So it took 16 minutes to go all the way around. So 4 minutes, so 4 out of 16 is equal to 1/4. So then that's right here. So here then we would be a height of the 38 plus the 4.4. So that's a height of 42.4 meters. At 8 minutes, so it's halfway through the ride, we're up here at the top, so that's 80.4. 12 minutes, that's 3/4 of the way, right? 12 divided by 16, 4 goes into there 3 and 3/4 of the way, so that puts us right here. So again then, we're that distance of 38 plus 4.4, so we're back at 42.4. 16 meters, we're back at the beginning, so our height is 4.4. 20, so it's another 4 minutes on top of there, so we've done 1 1/4 rotation, so we're up at 42.4. 24 minutes on the ride means that you've had 1.5 rotations, so you're up at 80.4. So there's your data. Now it wants us to sketch this graph. So there's 4, 8, 12, 16, 16. So this is our time in minutes. This is our height in meters. So every 4, I'm going to say, is 20. Okay. So now we plot our points. So at 0, we're at 4.4 meters. So it's just above that 4. At 4, we're at 42.4. Oops, that's a little bit high, but close enough. At 8, we were at 80.4. Oops, and I put that one over. We were at, what was it? 80.4. 12, we're back at 42.4. 16, we're back on the ground. 20, we're at 42.4. 24, we were at 80.4. Okay. So hopefully I've got my dots far enough apart. Okay, so our graph then, connect our dots. Oh, I kept going. I guess I didn't have to go quite so far. Okay. So our range is equal to our maximum minus our minimum So 80.4 minus 4.4, so that's equal to 76. So it's between, y is an element of real numbers. I just ran out of room, so I'm not going to put that. Your midline is your maximum plus your minimum divided by 2. So that's 84.8, which is 42.4 meters. So your midline is right here. Pretend that's nice and straight. And what don't I have for you? Oh, the amplitude. Your amplitude is your maximum minus your minimum divided by 2, so that is 76 divided by 2, which is 38 meters. And then the last one is your period, so the distance from maximum to next maximum, or the time, so 24 minus 8, which is 16 minutes. Okay, and that's all you need to know about periodic, or the graphs of periodic functions.